Hi, today we're going to look at analyzing a complex pulse sequence using the VSA software's pulse train analysis. And to demonstrate this, what we're going to do, and we can see already, is we have just over 3 milliseconds of capture comprising of about 130 pulses. And to the naked eye, we can see that there's some sort of repeating pattern, but there has to be a better way we can visualize this to understand how often this repeats and so on, other than brute force inspection. So from this overall capture of 3 milliseconds, we can have a zoomed in section of a few microseconds here of about 500 microseconds that we can now look at a little bit closer. And we can see a sequence of bursts and then some changing pulse widths that increase and then some sort of staggered and then another burst. We can see overall in our pulse summary that once again we have 130 pulses and some average figures and metrics, as well as the individual pulses themselves. And we see there's a uniqueness to the pattern from the modulation of them. We have several Barker-coded pulses and then linear FM, and triangular FM, and CW, and so on. So instead of trying to manually figure out what the sequence is going through here, we can simply use the new feature within the VSA software of our analysis capability called train scoring. And this is a really powerful feature that with it enabled, we can designate a series of pulses that we want to call an individual train. So in this case, we've selected pulses 1 through 7 to be defined as our first train, and they're copied to this reference table. And what we can see is that it automatically highlights whenever that particular pattern occurs. So we can see really quickly within our 3 millisecond capture that we see it not only once, twice, 3, 4, 5, 6, 7 different times for that specific sequence or that pulse train. And we could do this and define multiple trains here. In this case, I've already predefined them, but you can define them either manually or by copying already captured pulses. So again, now we can see that we have 7 occurrences of our second train that we defined, as well as here's our third train, and then here's a fourth train. So very quickly, we're able to see that there's 4 fairly unique pulse trains within this signal of interest that are repeating over and over again. One, we can see this at the broad level, but also at a granular level before the overall sequence repeats, we see how that looks, and it's all color coordinated. More importantly, not only do we have the captured pulses that we can see here in the time domain, as well as the individual pulse table, we have it color-coded in this pulse train search table. So the orange, blue, red, and green sequence is replicated here as well, so you can see exactly what pulses are part of each train color-coordinated. You can sort easily on the train ID, so you can look at all the pulses that occurred over time from one particular definition or the other and such. So it's a really powerful feature to be able to visualize very complex repeating pulse trains in a very complex environment, whether it's radar or electronic warfare signals. This pulse train score analysis is just one of many advanced pulse analysis features that are now available in the Keysight 89600 VSA software. Other great features like pulse detection, deinterleaving, long BPSK demodulation, time side low measurement, and many more are also available in the same software package.